we work on specifically artificial intelligence, and I specifically work on the photography aspect. So when you use the Google Pixel camera, which is currently the highest rated smartphone camera, that uses a bunch of AI features to boost up your photos, and that is powered by my team. My background, I was born and brought up in Bombay, India. I did my undergrad there, then I went to grad school here in the US. Knocking on everybody's door, get a bunch of data, put it on a spreadsheet, now we call it a data set. You put this on a graph, so bear with me. You took this same data that we have here, you put it on a graph, and you kind of see a trend. It's very intuitive, like the bigger the house, the higher the prices, stuff that you would have expected. So just from basic geometry, we draw a line for that trend, and then we take a closer look at that line. That line has this equation, and if we take a closer look at the equation, then we get to this particular form factor, which means that from our inputs that we put in, square foot and bedrooms, etc., we got to some prediction of a price. And if you look at it, this 112 and 0.7 is not something that I just guessed. It was these are actual constants that came from the data we collected from the neighborhood. Which means that if I put in my own square footage here, I should get some prediction of my price. And that is how all machine learning works. It's just this tiny little equation behind the scenes trying to understand what your final output should be, what your final prediction should be. So let's look at how you go from something like this machine learning model to something that is much more complicated, like the Siri voice recognition system. For example, the company that makes toothbrushes also makes toilet brushes, because that's how the supply chain works. So if I want to optimize for inventory and how fast I can stock it, I'll be stocking the toothbrushes right next to the other brushes that exist, or hairbrushes, because that's much faster. So I'm optimizing for the supply side. But when I buy a toothbrush, I usually also buy toothpaste, which is made by a different manufacturer. And so if I want to optimize for these guys, then I store them differently, which means that now supply is taking much longer to store. And Amazon thought of this as a very complicated problem in the sense of flow, where just like how cities kind of optimize for flow, where you have the same city trying to have, let's say, the power grid versus the water supply grid versus the sewage, traffic, both vehicular traffic, pedestrian traffic, transit traffic, as well as other scenarios if you have a metro and subway. All of these kind of interconnecting grids, all just to optimize the flow of people. If you just optimize one grid, it has negative effects on the other. So you want to kind of do a holistic optimization on everything, where nobody's completely happy, but everybody together is mighty happy. And that's what these guys did here, where the goal was to make the fastest way to minimize the amount of product that is stored in the warehouse.